Hey everyone, let's take a look at assignment 45 homework. Called 3.1 through 3.5 calc review. Okay, this has 11 questions. Let's get started. It says, using the limit definition of the derivative, find the derivative of the following. Okay, and I've been given the general derivative. F prime of x equals f. Oh no, it does not. It's the limit as h heads to 0 of f of x plus h minus f of x all over h. So our f of x in problem number 1 is y equals x squared minus 6x. So f of x plus h will be x plus h squared minus 6 times x plus h. Or x squared plus 2xh plus h squared minus 6x minus 6h. That's f of x plus h. We also need f of x, which is x squared minus 6x. And according to this difference quotient, we want to subtract. So these will cancel, and these will cancel. And so we're going to be left with the limit as h heads to 0 of 2xh plus h squared minus 6h all over h. Okay, well, then f prime of x will be the limit as h heads to 0 of h 2x plus h minus 6 all over h. And now we can do our direct substitution, and we get f prime of x is 2x minus 6. And surely you knew that if f was equal to x squared minus 6x, that the derivative of this would be 2x minus 6. But we were asked to show that we could do this by hand. Then I'm asked to, no, not add a point, just general derivative. Great. So that's 1 done. Let's take a look at 2. With 2, we're using the same limit definition of the derivative. So why did I put this one on the worksheet? Well, look at your f of x. Your f of x here is square root of 2x plus 3. So what I'm going to have to do is say the limit as h heads to 0 of square root of 2x plus h plus 3 minus square root of 2x plus 3 over h. Okay, so now what? Well, I could distribute it in here and get 2x plus 2h. But I can't subtract these, and if I put this in here, I'm going to end up with 0 over 0. So now I need some algebra magic. Remember what that was? That's right, we need to rationalize the numerator by multiplying by the conjugate. 2x plus 2h plus 3 minus square root of 2x plus 3. No, not minus, plus, because we're using the conjugate. Square root 2x plus 2h plus 3 plus square root 2x plus 3. So on top, I've got some FOILing to do. That's going to be the limit as h heads to 0 of 2x plus 2h plus 3 minus square root 2x plus 3 times square root 2x plus 2h plus 3 plus square root 2x plus 3 times square root 2x plus 2h plus 3. And then we have this one times this one with a minus in front, so we've got minus 2x plus 3 all over h times square root 2x plus 2h plus 3 plus square root 2x plus 3. Oh my God. Well, I better tidy this up, huh? Okay, so let's get rid of those and commence tidying. Well, minus this times this plus this times this, they cancel. So now I've got the limit as h heads to 0, 2x plus 2h plus 3 minus 2x. Don't forget to distribute. Minus 3 all over h square root 2x plus 2h plus 3 plus square root 2x plus 3. Okay, I can combine some like terms. And this h can cancel that h. So now I've got the limit as h heads to 0 of 2 on top, and on the bottom, square root of 2x plus 2h plus 3 plus square root 2x plus 3. Fabulous. Now I think I'm ready to do my direct substitution. If I put a 0 in for h, this becomes 2 over square root of 2x plus 3 plus square root of 2x plus 3. One of them plus one of them will make 2 of them. Square root of 2x plus 3. These can cancel, and so then I know that f prime of x equals 1 over square root 2x plus 3. Okay, but you're not going to be able to do this problem if you forget about the conjugate. So please don't forget about the conjugate. That was problem number 2. Problem number 3 says we need to find f prime of c using the limit as x approaches c, f of x minus f of c, c over x minus c. And our function y equals 1 over 2x plus 3, and our c value is -2. So I'm looking for the slope at this point on this function. And to find that, we need to use this limit definition. So f prime of -2 equals the limit as x approaches -2 of f of x minus f of -2. -2 plus 3 is -1. 1 over -1 is -1. Okay? All over x plus 2, because minus c minus is plus. Well, I think I can -2 limit x approaches -2 of 1 over 2x plus 3 plus 2x plus 3 over 2x plus 3 all over x plus 2. So now I've got f prime of 2 equals the limit as x approaches 2 of 2x plus 4 over 2x plus 3 times 1 over x plus 2. I'm doing the flip and multiply thing. You also notice over here that I could factor out a 2, so that will cancel out. When I plug a 2 in now, 2 times 2 is 4, 4 plus 3 is 7, and I have a 2 on top. So 2 over 7. So f prime of 2 equals 2 over 7. All right, what's next? Number 4. 4 says, given that f of x equals -x squared for x less than 0 and 4 minus x squared for x greater than or equal to 0, A, write the equation for f prime. So f prime is going to be -2x for x less than 0 and -2x for x greater than or equal to 0. Huh, isn't that interesting? The same function on either side. Well, that's very reasonable. All right, I wrote the equation for f prime. Part B says sketch f and f prime in the same window. Okay, so f is a down-pointing parabola over here. -1, -1, 0, 0, and that's actually an open circle there. And then here, 4 minus x squared could be equal to 1, 3. Okay, so there's my graph of f. Now what about the graph of f prime? Well, the f prime graph is simply y equals -2x. Y equals -2x. That's f prime. F prime. But this function is not continuous at x equals 0. So the derivative can't exist there either. If you had made just the linear equation filling in that hole, that would not be the correct graph of f prime. Okay. What's next? I labeled each. Good. I guess I need to put f of x on the green one. Evaluate f prime of -3. Well, that's where -3 would live, and if I plug in the -3 here, I'm going to get f prime of -3 equals -2 times -3 or +6. Okay, what about f prime of 2? Well, f prime of 2 is going to be -2 times 2. So f prime of 2 will be equal to -4. Right? Because I'm plugging into this piece because 2 is greater than or equal to 0. Alright, that was part C. Part D, explain the answers in part, what your answers in part C represent. Oh, well, this represents the slope at x equals 2 on the graph of f. Okay? Okay. And the other one represented the same thing, except it was the slope at -3 on f of x. So I was finding the slope over here at -3, and I was finding the slope over here at +2. Alright. 5. Given y equals this parabola, find the equation of the normal at 317. Okay. So, this is number 5. Y equals 3x squared minus 4x plus 2. Well, we need a point and we need a slope. The ordered pair was given to us as 317. That was very nice. And so we need y prime of 3. So y prime is going to be 6x minus 4. Y prime of 3 is 6 times 3 times 4. Y prime of 3 equals 14. So now I have a slope, I have a point, I can write the normal line. So y minus 17 equals, am I plugging 14 in? No, that's the tangent line. The normal line would be this slope, -1 over 14, x minus 3. So there's my normal line equation. That's number 5. Okay, number 6 says given y equals -1/3 x to the third plus 2x squared minus 4. Find the equation of the derivative. Okay, y prime equals -x squared plus 4x. And I did that by bringing down the 3. -1/3 times 3 is -1. Subtract 1 here to get x squared. The derivative here, I'll bring down the 2. 2 times 2 is 4. And subtract 1 to get x to the first. Alright, that's part A. What's part B says? The largest value of the slope. Well, the largest value of the slope will be a maximum on the y prime graph. Okay? If I factor out a -x, I have x minus 4. Okay? So here's my y prime graph. X equals 0, x equals 4. That point right there, this is y prime, and that point is when y prime has a max. Well, where is that? I of course could do second calculate maximum, but I remember from algebra 2 and pre-cal that if this is 0 and this is 4, then halfway in between at 2 we should have our maximum. Now this question says find the largest value of the slope and at what x value does it occur? Well, we found the x value to be 2, and now because this is a y prime graph, I don't plug the 2 into here. I would be position, right? I plug the 2 into y prime because I want to know a y prime value. So y prime of 2 equals -2 squared plus 4 times 2. So that's +4. Okay. 2, +4. So the answer to question B is the largest slope is 4, and that happens at x equals 2. Okay, so that was part part B. And now part C says find the x and y intercepts of the tangent line at -1. That's interesting. Find the x and y intercepts of the tangent line at x equals -1. So I need an ordered pair, which means I'm going to plug a -1 in there. So f of -1 equals no, that's the right, no, that's the right function. Equals -1/3, -1 to the third plus 2 times -1 squared minus 4. Okay, so what are we going to have? This is going to be negative times negative is positive. Here I have +1 times 2 is 2 minus 4. So 7/3 minus 12/3 -5/3. So we know that f of -1 equals -5/3. But what about f prime of -1? We need that as well. So let's find f prime of -1 by plugging -1 into this function. -1 times -1 minus 4. That's going to be positive times -5 and -5. So now I have a slope and I have a point. And in number 6, we're writing the equation of a tangent line. So I've got y, that's f plus 5/3 equals -5x plus 1. All right, so there's the tangent line equation. But wait, we were supposed to find the x and y intercepts of this tangent line equation. So y equals -5x minus 5 minus 5/3. So that's -5x minus 20/3. I multiply top and bottom here by 3/3, so that I have a common denominator. So that's what y equals. That's our tangent line. And if I want to find a y-intercept, I set x equal to 0. And when I do that, I have -5 times 0 minus 20/3. And I get -20/3 as the y-intercept. Now what about x-intercept? That's right, I set y equal to 0 in that case. -5x minus 20/3, or 20/3 equal -5x. And then I divide by 5. I end up with x equals 4/3. Because I can take a 5 out of both of these. Alright, so that's my x-intercept. And that's my y-intercept. Okay. And what are we looking for, just to be sure? Of the tangent line. Okay, the tangent line is linear and therefore only has one x-intercept and one y-intercept. Okay, which problem was that? That was problem number 6. Let's move on to problem number 7. 7y equals 4x squared minus 8x plus 1. Find the first derivative. Okay, so y prime equals 8x minus 8. 8. Y equals x plus 1, 3 minus x squared. So you're welcome to FOIL this out. Y equals 3x plus 3 minus x to the third minus x squared. And then I could take the derivative of this. That would be 3 minus 3x squared minus 2x. Or negative 3x squared minus 2x plus 3. That's y prime. Or I could use the product rule. So y prime is this times the derivative of that. The derivative of that is minus 2x plus this times the derivative of that. So what do we have here? We have x equals negative 2x squared minus 2x plus 3 minus x squared. And that's going to be negative 3x squared minus 2x plus 3. Ta-da! Same. Okay, so that was number 8. Number 9, a quotient rule, if you will. Okay. 9 says y equals x squared plus 5x minus 1 all over x squared. You know, I'm seriously tempted to split this into 3 fractions. X squared over x squared plus 5 over x squared minus 1 over x squared. And so then I get y equals 1 plus 5x to the minus 2. Oh, there's an x on top. X squared on the bottom, so I have minus 1 minus x to the minus 2. And then I could take the derivative of this and have negative 5x to the minus 2 plus 2x to the minus 3. And of course, if I factored out an x to the minus 3, I'd be left with negative 5x plus 2. Negative 5x plus 2. Alright, there's my y prime. Either of these would be fine. Now, instead of splitting it up, let's just use the quotient rule. Low d high minus high x minus 1 d low 2x. Okay, over low squared. Alright, so up top I'm going to have 2x to the third plus 5x squared minus 2x to the third minus 10x squared minus 2, no, minus and minus will be plus 2x all over x to the fourth. Okay, well, where can I go from there? 2x to the third minus 2x to the third, they cancel. I can do minus 5x squared on top plus 2x over x to the fourth. And here I can pull out an x from the top, and I'm going to have x minus 5x plus 2 over x to the fourth. This cancels that, and lo and behold, these are the same. Alright, that was problem number 9, done 2 different ways. And what about problem 10? You know, if you haven't tried 10 already, why don't you stop the little interest and come back in a minute. 10. Y equals x squared minus 9 over 3. Well, I don't want to use the quotient rule here. I mean, I will, but I actually want to start by saying, you know, I could pull that 1/3 out, and I could distribute that 1/3, and so that's going to be 3. So now if I want y prime, that's going to be 2/3 x. That's a pretty fast way of finding y prime. Some people, though, insist on using quotient rule here, so y prime could be low d high minus high d low. The derivative of the constant is 0, all over low squared. So then this y prime is going to be 6x minus x squared plus 9 over 9. And that's not the same. Huh. Yes. X squared over 3 minus 3. That's good. Derivative 2/3 x. I like that. And I'm going to go back over here and say low d high. Yeah? Minus high d low. I like that. Oh, it's 0 times that stuff. No wonder. Silly me. And so I can take a 3 out of both of these, and I end up with y prime equals 2x over 3. Same. Alright, and then finally problem number 11. A particle moves in one direction on a straight line, given by s of t equals 6t squared. Feet from the origin. Find the average velocity on 2 to 4. Average velocity on 2 to 4. Well, we know that's going to be s of 4 minus s of 2 over 4 minus 2. So if we plug a 4 in here, 4 squared is 16, times 6 is 96, and if we plug a 2 in there, we have 24, and so we're going to get 72, yeah, over 2, or 36, and do we have any units? We don't have any feet. Okay, so this is 36 feet per minute is the average velocity on 2 to 4. Okay, there's part A. Part B says find the instantaneous velocity. Well, we know that v of t is the same as s prime of t, and if we want to know that instantaneous velocity at time equal to 2, we want v of 2, or s prime of 2, so that's 12 times 2, because I need to take the derivative of s to get s prime. And so that's going to be 24 feet per second is the velocity at t equals 2 seconds. Alright, and then finally part C. Part C says acceleration when velocity equals 3. Well, I have to find out when velocity is equal to 3, and then take that time and plug it into the acceleration equation. So if velocity is the derivative of this, and that's 12t, acceleration is going to be the derivative of this, which is a constant. So I don't actually need to do anything with velocity, but, you know, the intent was 3 equals the velocity equation. And so we want to know when t equals 1/4 second, what is acceleration? Except that I don't have a place to plug the time. I just have a constant there. All right. So there we go. That's 45 homework, 2.1 through 3.5 calculus review. I hope that was helpful for you. Tests coming.